Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. This is Abdul Ghaffar Abbasi here. Today we will discuss very important topic, that is the formulae, stoichiometry and mole concept. Bismillahirrahmanirrahim. These are the contents of the day. Atom. What is atom? Then fundamental particles of atom. What about charges, like positive and negative charges? Atomic number, represented by the Z, capital Z. Atomic weight, atomic mass or nucleon number, represented by capital A. Then molecular mass, formula mass, and then calculations of the molecular mass and formula mass. Then mole and its calculation. Then we also discuss the relative atomic mass, relative molecular mass, then percentage by mass of an element in a compound, how to calculate, then empirical formula and its calculations, molecular formula and its calculation, Avogadro's number and its calculation, limiting reactant, concentration and its calculation, and last, calculate the percentage yield and percentage purity. So these are the contents of the day which we will discuss one by one. So now this is the first point, that is atom. Old concept related to atom. A means not, atom means divisible. This was the definition of the atom. Atom is the smallest particle of matter. It cannot be divided into simpler units. This was the old concept related to atom, but this is the modern concept, that atom can be divided into further simpler units. Like you can say that these are the fundamental particles of atom, like electron, proton and neutron. Atom can be divided, and these are the fundamental particles like electron, proton and neutron. So what are the properties of these fundamental particles? Like electron, the charge on the electron is negatively charged particle, and the unit of the charge is coulomb. And what is the charge, amount of charge? That is 1.602 into 10 minus 19 coulomb. And what about the mass of the electron? That is 9.109 into 10 minus 31 kilogram. This is the mass of the electron. Now what about the properties of the proton? It has the positively charged particle. It is the positively charged particle, proton, and it is represented by small p. Unit of charge is coulomb, same, and the charge 1.062 into 10 minus 19 coulomb, and the mass of the proton is 1.672 into 10 power minus 27 kilogram. Now the last fundamental particle, that is neutron, represented by small n, and it is no charge, it is neutral particle. Unit of charge same, that is coulomb, and the charge, amount of charge, as you know, that is it is neutral particle, so it has no charge. And mass of the neutron is 1.76 into 10 minus 27. So these are the fundamental particles like electron, proton and neutron, and their main properties. So when we go through these you can say that properties, so we can conclude that electron is negatively charged particle, proton is positively charged, and neutron is neutral, or it has no charge. Now this is the structure of atom, that where electrons, protons and neutrons are present. Like look at here, proton and neutrons are present at the center, and they make nucleus. This is the nucleus, and then these are the electrons which are revolving around the nucleus. Electron has negative charge, nucleus is positively charged, so there is attraction between positive and negative charges. That is the reason electron is revolving around the nucleus, and these are called as the shells or orbits where electrons are present. So this is the structure of the atom. Now what about charges? As we have discussed, same charges always repel each other. Like positive they will not attract, negative they will not attract. Like this is the same concept in the magnets, like north pole they will not attract, south pole they will not attract, but opposite charges always attract each other, like positive and negative and positive they will attract each other, like north and south pole they will attract. So this is the same reason that electron is revolving around the nucleus, because electron has a negative charge and nucleus has the positive charge. That is the reason it is revolving around the nucleus. Now atomic number, that is represented by Z. What is the definition of the atomic number? The number of protons or electrons in an atom is called the atomic number, and it is represented by the capital Z. Example, hydrogen has 1 proton, so its atomic number is 1, and helium has 2 protons, so its atomic number is 2. Say suppose carbon has 6 electrons, so it's 6 protons, so its atomic number will be 6. So proton number or atomic number is directly proportional to the number of protons or electrons in an atom, especially protons. Now what about atomic mass, weight or nucleon number? That is represented by the capital A. The number of protons and neutrons means P plus N. Proton and neutron in an atom is called the atomic mass or atomic weight or nucleon number, or in other words we can say sum of protons and neutrons in an atom is called the atomic weight. Now the example, helium has 1 proton and 1 neutron, so its atomic mass will be 2. It will be 2, not 1, it will be 2, because we have to add. Now look at this one, second example, like carbon has 6 protons and 6 neutrons, so its atomic mass will be 12. This is correct. Now what about molecular mass and formula mass? Definition: the sum of atomic masses of all elements present in a compound in a molecule. Sum of atomic masses of all elements present in a molecule will be called as the molecular mass. It is represented as AMU, atomic mass unit, like CO2, carbon dioxide, 12, 16, 16, 12 for carbon and 16 for oxygen and 16 for another oxygen, so total will be 44 AMU. And then H2O, hydrogen 2, oxygen 16, total 18 AMU. This is the way how to calculate the molecular mass. Now the second one is the formula mass, the sum of the atomic masses of the all elements present in a compound, and it's also represented as AMU, atomic mass unit. Say suppose NaCl, sodium 23, chlorine 35.5, total will be by adding these two values we will get 58.5. Now KOH 39 for potassium, 16 for oxygen, 1 for hydrogen, total 56 AMU. So these, what is difference between formula mass and molecular mass? In molecular mass mostly we will write the molecules like having covalent bonding, or we will count the covalent compounds. But when we are going to discuss this formula mass, we will write the ionic compounds and there will be ionic bonding. So this is the main difference between formula mass and the molecular mass. Now we are discussing what about relative atomic mass, that is represented by ER, and relative molecular mass. Relative atomic mass AR of an atom is the average mass of one atom of that element compared to 1/12 of the mass of the one carbon 12 atom. So what about relative atomic mass? Just that will be the same like atomic mass and molecular mass, but here we are comparing the mass with the standard element, that is carbon. It has no unit because it is ratio, and AR of an element is average mass of the one atom of the element, and that will be divided by 1/12 mass of the atom of the carbon 12. So this is a formula how to write the relative atomic mass, and this is very important diagram, that what is the concept of a relative atomic mass. So this is the standard element, that is carbon. Carbon 12 is used as the standard element for relative atomic mass in the periodic table. This is the carbon and 12, and hydrogen is at this position 1, and oxygen is at this position 16 atomic mass, magnesium 24 and sulfur 32. Now how you will compare hydrogen 1 and carbon 12? So one carbon atom is 12 times as heavy as hydrogen. So this is the way how to compare and how to relate, why we compare this with the carbon, and why we call it as the relative atomic mass, because the standard element is carbon, and then through this we can compare and write the relative atomic mass in the periodic table. So one carbon atom is 12 times as heavy as the hydrogen. Then what about oxygen and magnesium? Oxygen is 16 and magnesium is 24. One magnesium atom is 1.5 times as heavy as the oxygen atom. Now the last one is the oxygen and sulfur, that is 1632, means double 16 and 32. So one sulfur atom is twice as heavy as the one oxygen atom. So this is the concept of the relative atomic mass, and we will compare the other atomic masses with the carbon. Now another very important topic, that why are some relative atomic mass values are not whole numbers. Like this is the example of the chlorine, that is the answer we will get. What is the relative atomic mass of chlorine? That is 35.5. What is the reason why it is not the whole number? It is because that these elements exist as a mixture of isotopes, and the relative atomic mass is thus calculated on the basis of relative percentage of their isotopes. So that is the reason it is in point form, decimal system. Now say, suppose example, chlorine exists as chlorine 35 and 37. A typical sample of the chlorine has 75% of chlorine 35 and 25% of chlorine 37 atoms. So how we can find the relative atomic mass? Now look at here, 75% out of 100, and then multiply by the isotope, that is 35. Then we will add the 25% out of 100, so divided by 100, multiply by the 30 chlorine 37, the atomic mass. So now when we will add, we will get 26.5, 26.25 and then plus 9.25. when we add we will get 35.5. that is the reason that some atoms have the relative atomic mass in the decimal system, because they are found in the isotopes. Now we are discussing another important, that what about relative molecular mass. Relative molecular mass MR of an atom is the average mass of one molecule of that element or compound, and that is compared with 1/12 of the mass of the 1 carbon 12 atom. It is the ratio, so it has no unit, and it will have the same formula like we have discussed in relative atomic mass. MR of the molecular substance is average mass of one molecule of the element or compound divided by 1/12 mass of the an atom of the carbon 12. Example, for example, MR of the CO2 carbon 12, oxygen 16 multiplied by 2, we will get 44. This is the way how to calculate the MR of the compound, which you know already we have discussed. MR of the water, hydrogen 2, oxygen 16, it will be 18. MR of calcium carbonate, that will be calcium 40, carbon 12, oxygen 16 multiplied by 3, that is 100. And MR of the ammonium carbonate, ammonia, nitrogen 14, hydrogen 4, then this complete will be multiplied by 2, then carbon 12, and then oxygen 16 multiplied by 3 because oxygen 3, then we will get the 96 total. Then MR of the copper sulfate hydrated with water, copper 64, sulfur 32, and then oxygen 16 multiplied by 4, then water has the 18, then we will multiply it by the 5, that will that will be 252, that will be 252 total. So this is the way how to calculate the MR of the compounds. Now this is the summary plenary of the topics which we have discussed. Number 1, relative atomic mass AR of an atom is the average mass of the one atom of that element compared to the 1/12 of the mass of one carbon 12 atom. This is the definition of the relative atomic mass. What about relative molecular mass? Relative molecular mass of an atom is the average mass of the one molecule of that element or compound compared to the 1/12 of the mass of one carbon 12 atom. This is the definition related to the MR. Now relative molecular mass MR of the molecular substance is the sum of relative atomic masses of the all atoms in a substance. Just you have to add all the atomic masses of the atoms in a molecule, then you have to add, and then we will get the total MR of the compound. Last one, relative formula mass MR of ionic compound is the sum of the relative atomic masses of the all atoms in the formula of a compound. Just we have to add the atomic masses, and then we will get the MR of the compound. So this was the summary related to the topics which we have covered. Now the very important topic, that how to calculate the percentage by mass of an element in a compound. How to calculate the percentage by mass of one element in a compound. Now say suppose percentage by mass of carbon, we have to calculate the percentage by mass of carbon in CO2. The question will be, these are the questions which I have taken from the past papers. So the mass of the carbon we will write here, that will be 12, and then the mass of the total compound we will write, that will be 44, and then it is, if it is percentage, so we have to multiply it by the 100. So this will be not 1, it will be 100. This is not the 1, this is 100, directly we will write. So this will be the 100. Then 27.3 percentage of the carbon and CO2. So another formula, like how to calculate the percentage, we will write the marks obtained, and then we will divide the total marks and multiply by 100. This is the formula how to calculate the percentage. So this is the same formula we are using in this percentage by mass of an element in a compound. Percentage by mass will be suppose that will be the marks obtained, and the total marks will be the mass of the compound. Like the mass of the carbon, that is 12, multiply by the total mass of the CO2, that will be 44, and then it will be multiplied by 100. We will get this answer. Same percentage by mass of hydrogen in water. What is the percentage by mass of hydrogen? That is 2, water, that is 18, and then multiply by 100. We will get 11.1 answer, 11.1 percentage. Now percentage of copper in copper sulfate hydrated 5H2O. What is the mass of copper? That is 64. And what is the mass of the copper sulfate hydrated? That is 250, and then multiply by 100, that will be 25.6 percentage. Wait, now look at here, this we have calculated, that is 252. So this will be 252, answer will be 252 here. So total will be 25.6. Then percentage by mass of oxygen in ammonium carbonate. So what is the percentage of the oxygen? Oxygen 3, 16 multiplied by 3, 48. Then total mass of this compound will be 96, and then multiply by 100. So we will get the answer, that is 50 percentage. So this is the way, this is very important topic and very easy, that how to calculate the percentage by mass of an element in a compound. It is very easy, it is very similar to the percentage like which we are calculating the percentage of the marks. Now molar mass definition: the relative molecular mass expressed in grams is called the molar mass. That will be, you can say that, similar to the mole. It has unit, that is gram, and it is represented in the grams. Say suppose molar mass of NaCl is 58.5 gram, molar mass of the KOH is 56 grams. That is quite similar to the mole. Like what about mole? Atomic mass, molecular mass, or formula mass expressed in grams, it will be called as a mole. Like 1 mole of NaCl will be equal to 58.5 grams. 1 mole of KOH will be equal to 56.56 grams. So this is the definition of the mole. Now we are moving towards the calculation of the mole. This is the basic formula of the mole, and then we can derive the formula and get two other formulas. Like this is the basic formula which you people have to remember. Number of moles is equal to mass, that will be given in the question, then divided by relative atomic mass, relative formula mass, or relative molecular mass. This is the formula number 1. Then when you are modifying this equation and finding the mass, then what will happen? This will multiply with this one. So number of moles will be multiply by the atomic mass, formula mass or molecular mass. Then say suppose the third one, for example, you are finding the molecular mass here. So what will happen, just you have to exchange these. Molecular mass will be equal to mass given, that will be here, and divided by the number of moles. So these are three very important formulas, and then we will calculate some problems related to these three formulas which are very important. Now the question related to the formula number 1, that calculate the number of moles in 89 grams of the following compounds. So for example, water, CO2, calcium carbonate, potassium hydroxide and sulfuric acid. Formula is mass, given mass divided by relative atomic mass or relative molecular mass. So given mass is 89, that will be same in all the questions. Look at here, 89, 89, and then it will be divided by the atomic mass of that compound or molecular mass of that compound. That will be different, like water, that will be 18, and when you divide it you will get the answer 4.944. you have to give the answer, write the answer into decimal system, and then after the decimal you have to write three numbers. Then CO2 8944 is the molecular mass of CO2. Then when you divide you will get 2.022 answer, and this will be moles. You will write as you have calculated the number of moles of CO2. Then calcium carbonate 8900 is the relative molecular mass of calcium carbonate, so answer will be 0.89 moles of CO2, CaCO3. Potassium hydroxide 8956 is the relative molecular mass, answer will be 1.589 moles. Last one, sulfuric acid 89 divided by 98 is the MR of the sulfuric acid. We will get the answer 0.908 moles of sulfuric acid. So this is the you can say that these are the questions, problems related to the formula number 1. Now the formula number 2, calculate the mass of moles, calculate the mass of the following in the 15 moles of the following compounds. So how to calculate the mass? Mass is equal to number of moles multiplied by AR or MR. So H2O, number of moles, that is given 15, and what about the MR or AR of the water, that is 18. When you multiply it you will get 270 gram, that is the mass. CO2 15, same, we will write the number of moles, and 44 will be AR, and when you will multiply it you will get 660 gram, that is the mass. So this is the problems, these are the questions, these are the problems related to the formula number 2. Now the formula number 3, that is the last formula, that how to calculate the MR of the compound, that will be calculated by you can say that mass will be given and divided by the number of moles. This is the third formula which we have already discussed. So question is that calculate the MR of the following compound in 45 grams and the 10 moles. So 45 is the mass which we have written here, 10 is the number of moles. When you divide you will get the 4.5 will be the MR of that compound. So this is the way how to find the MR of the compound formula number in formula number 3. So these are the questions related to the moles. Now the last topic which we are discussing, which is very important, that what is empirical formula and how to calculate the empirical formula. What is empirical formula? It represents the simplest ratio of atoms present in a compound. Simplest ratio, say suppose this is the simplest ratio, for example 6 and 6, you have to divide it by the same number, like 6 1 the 6 and 6 1 the 6. So this is called the simplest ratio, means you cannot divide it further. This the number will be the smallest, or that will be the simplest ratio. So this is the way how to find the simplest ratio. It can be determined through the experiments. Say suppose example, empirical formula of benzene, actual formula is C6H6, that will be CH. Why? Because as right now we have discussed, take the simplest ratio, 6 1 the 6, 6 1 the 6, so 1 1 means C and H. Empirical formula of glucose is C6H12O6, 6 1 the 6, 6 2 the 12 and 6 1 the 6. So 1 2 1 will be the simplest ratio, say suppose C1 H2 and O1. So this is the empirical formula of the glucose. So in empirical formula we have to just simplify it, and then we will get the answer, that will be the empirical formula. Now how to calculate the empirical formula, that is very important, and this is very important question, and it will appear in your exam. These are the 5 rules. Identify the mass of the elements present in the compound, that will be given in the question. AR of the elements, or that will be also given in the periodic table. Then we have to calculate the number of moles. When you divide the mass with the AR of the element, that will be the number of moles. Then find the simplest ratio. How to find the simplest ratio? The number of moles which you have calculated in a step number 3, just you have to go through the answer, and then you have to divide the answer by that answer which is the smallest number. That will be clear when we will solve the question. Then we will get the simplest ratio in this way. Then we will get the empirical formula. Now look at this one example. A compound containing 2 elements, that is magnesium and oxygen, and having the masses that is given like 1.20, 0.80. So now how to calculate? You have to apply these rules. Now you have to write the masses, that is 1.20 and 0.80. AR of the compound 20 element, that is 24, oxygen 16. Now how to calculate the number of moles? Just divide this number by the AR. So we will get 0.05 number of moles and 0.05 number of moles. Now the mole ratio or simplest ratio, how can we calculate? As I have told you earlier, that we will divide the answer which we have obtained here at this step number 3. We will divide that answer with the smallest, but here the answer is the same, so we will divide the number with the same, like 0.05 will be divided by 0.05, or 0.05 will be divided by 0.05. Answer will be 1 1. Then it means magnesium will be 1 and oxygen will be 1, that will be magnesium oxide, the empirical formula of the magnesium oxide. For example, say suppose the answer which we have obtained here, that is 0.8, and the answer which we have taken here, obtained here, that is 0.2. So what will happen? This 0.2 is the least number, smallest number, so it will divide this number like 0.02, and it will divide itself also 0.02. So we will solve these type of questions in our upcoming lectures. So the main concept is that you have to, in this step, you have to divide the answer, all the answers, with the smallest number. So the number which you will obtain, that will be finally, that will be the empirical formula. This is the way how to calculate the empirical formula. Now we are moving towards our last topic, that is molecular formula. It represents the actual ratio of atoms present in a compound. We will not calculate or count or find the simplest ratio, but we will write as actual number of atoms present in a compound. it can be also determined through different experiments. For example, empirical formula of benzene will be C6 and H6. Empirical formula of glucose will be C6H12 and O6. Same. So this is molecular formula. Oh sorry, this we will write not empirical formula, but this will be molecular formula, right? This will be molecular formula of benzene, and the molecular formula of glucose will be C6H12 and O6. Now how we can calculate the molecular formula? By the two steps. Number one, n means number. N is basically an integer or a number which we will obtain by dividing the molecular mass which will be given in the question divided by the empirical formula mass. Empirical formula which we have, which will be given, and then we have to calculate the empirical formula mass, and then we will divide, then we will get a number, and that number will be put into the second step, that we will write the empirical formula here and then multiply by that number. Now we are solving this molecular formula, that will be very much clear then. Now empirical formula of ethane is CH3. This empirical formula is given that the relative molecular mass, that will be also given, that is 30. And now what about the molecular formula? How to calculate molecular formula? So as we have discussed that there are two steps. Now first of all, data is MR of the compound is given, that is 30, and empirical formula mass of this CH3 carbon 12 hydrogen 3, that will be 15, that is also calculated. Now we have to find the molecular formula. How to find the molecular formula? By two steps. Number one, n, molecular mass given, that is 30, divided by the 15. This is the step number one which we have discussed. Molecular mass given, that is 30, and 15 is the empirical formula mass which we have calculated here. Answer is 2. Now what we will, where we will place that 2? Look at here, empirical formula we will write in the bracket and then multiply by that number. So empirical formula is CH3 multiplied by 2, that will be C2H6 will be the molecular formula of ethane. So this is the way how to find the empirical formula and then find the molecular formula. So I hope you understood these very important topics, and these are very important on the paper point of view. Thank you. Allah Hafiz.